Hello, Math 3 students. This is a supplemental video. It's optional. You may watch as much or as little as you'd like. You received 2 extra worksheets today, and you may have finished them during class. If you didn't, they're due tomorrow. So this is on factoring trinomials. I'm going to just work all the odd problems from both worksheets. So again, you can fast forward. If you already know how to do the trinomials where the a equals 1, then you can fast forward through this part. If you don't, you may work along with me and do the odds. You're responsible for the evens yourself. But we really need to get better at this, especially for our rational functions unit. This just needs to be second nature, factoring these. So trinomials are polynomials where you have a degree of 2. So you have an exponent of 2, an exponent of 1, and then you have a constant. And what we do is we factor these into 2 binomials, two-term polynomials. So each of these, though, the a value is just 1. So every one of the first terms has just a 1, or would have a 1 in front of it if we put that there. And so these are really the easiest types of trinomials to factor. So if you remember these, great. Go ahead and fast forward through this. You don't have to watch it at all. If you don't remember them, then work along with me. All right, so for each of these, I'm going to be factoring them into 2 binomials. So I'm going to go ahead and put my parentheses there. I'll go ahead and put my b in each parentheses because I know that's going to be there. And then if I see 2 pluses, I also know that I'm going to have 2 pluses in my parentheses. So I can go ahead and put those there too. What I'm looking for is I'm going to look at my constant. I need a factor pair, or 2 numbers that when I multiply them times each other equals my constant. And then my middle term, those same 2 numbers when added together need to equal my middle term. It's not always, well, it is always added together because it might be a negative and a negative, it might be a negative and positive, so I'm gonna leave that there. So I need to look at my constant 7 and figure out what 2 numbers will multiply to get 7. Well, 7 is a prime number, so the only factor pair there is for 7 is 7 and 1. And if I put in a 7 and a 1 here, multiplied together, that equals 7. And then if I put a 7 and 1 here, added together, that does equal my middle term. So those are the 2 numbers that I need, 7 and 1. And then so if I multiply this back out, I should get this trinomial. If I don't, I'm wrong. But anyway, so that's how you do that. Let's look at the next one. Let's look at number 3. I need a factor pair for negative 90 that will give me 1 if I subtract them. So one number needs to be positive and one number needs to be negative. So I'm going to go ahead and put my parentheses again, my m in each one. And I know it's going to be 9 and 10. I'm not going to write those over here because I don't want to have to erase them a million times. But I know it's going to be 9 and 10. So I'm going to go ahead and write 9 and 10 in here. And then what I need to decide is which one needs to be positive and which one needs to be negative. Well, I need to end up with a positive 1. So that means the 10 needs to be positive and the 9 needs to be negative, because 10 plus negative 9 is my positive 1. And then 10 times negative 9 is the negative 90. Okay, so let's move a little bit faster. Put my n in there. I need a factor pair for 9 that adds up to 10. That's going to be 9 and 1. And they are both going to be negative. Negative 9 plus negative 1 is negative 10. Negative 9 times negative 1 is positive 9. Okay, the next one. I need a factor pair for negative 24. Now look, let me give you a hint. If you've got a negative right here, then one of your numbers is going to be positive and one's going to be negative. If you've got a positive right here, they're either both going to be positive or they're both going to be negative. So I need a factor pair for negative 24 that when I subtract those numbers, or when I take the difference of those numbers, I get 2. So that's going to be 6 and 4. So let's put a 6 here and a 4 here. One of these is going to be positive and one's going to be negative. And the only way to get the positive 2 is if the 6 is positive and the 4 is negative. Okay, so moving on, here's number 9. I need a factor pair for 40 that when I add or subtract, I get 13. That's going to be 8 and 5, both negative. Negative 8 plus negative 5 is negative 13. Negative 8 times negative 5 is positive 40. Okay, so over here I need a factor pair for negative 56, and that's going to be 7 and 8. And let's see, 1 is positive, 1 is negative. The 8 needs to be negative, the 7 needs to be positive. 7 minus 8 is negative 1. And 7 times negative 8, negative 56. All right, number 13. Same thing, factor pair for 8, that when I add them together, I get negative 6. They're both going to be negative because I've got a positive here and a negative here. So it's got to be 4 and 2. Negative 4 and negative 2 added together, negative 6 times each other, positive 8. Okay, so here's where we get to a little bit more complicated problem. Number 15, we have an A that is not 1. So if your A is not 1, you got an extra step, if possible. Since all of these numbers are even, what I can do is I can take out the greatest common factor of 2, and then that leaves a trinomial in the parentheses that is has an A value of 1. So what is half of 108? 54. I am not thinking straight today. Okay, so then I just leave my 2 and I do my 2 binomials, and this and in this case I've created a trinomial where the A value is 1 by taking out that 2. So let's see, factor pair for 54, that's going to be 9 and 6. One needs to be positive, one needs to be negative. The 9 is going to be positive, and the 6 is going to be negative. Yep, okay. Number 17, same thing. All of these are even numbers, so I have a common factor of 2, so I'm going to take that 2 out. Okay, so now I've created a trinomial where the A value is 1. So then I can just keep your 2. You don't want to get rid of it. If it had a 0 over here, then you could get rid of it. But we want to make sure that we keep the 2, because remember, that's the A value. That's that the compression or stretch when you have a quadratic. So let's see. I need a factor pair for 30 that adds up to 11, because both of these are positive. So I'm going to have K plus something and K plus something, and that is going to be 6 and 5. Okay, number 19. Oh, okay. Well, this one doesn't have a factor that I need to pull out of everything, so I'm left with an A value of 1 anyway. So let's see. Oh, there's just 10 and 1 in it. So P plus 10, P plus 1. All right. So here we have the last 3 odd problems. 21. I need to pull out a 2. Okay, and then keep that 2 there. That's going to be P plus 2 and P minus 1. Yep, 2 minus 1 is 1, and 2 times negative 1 is negative 2. Okay, number 23, I've already got the A value of 1, so just need to figure out what my binomials are going to be. Because I have a plus here and a minus here, both of them are going to be negative. And it should be 10 times 5. 10 and 5. Yep, that adds up to negative 15 and multiplies to positive 50. Okay, so the last one on this page, I have a negative here. Anytime you have a negative here, one of them is going to be positive, one's going to be negative. So let's see, that would be 6 and 3. I need my 6 to be positive and my 3 to be negative. And just checking that real quick, 6 minus 3 is positive 3. 6 times negative 3 is negative 18. Okay, so this is where they get a little bit trickier. When you have an A value that is greater than 1, and you don't have a greatest common factor that you can take out to make the A value 1, we have to go through a process that's a little bit longer than what we've been doing. You might have been shown some sort of a magic square or an X or something like that. I choose not to use those little trick things to do these. I'm going to show you the steps. I'm just going to tell you what the steps are. So the first step is multiply your coefficient of your first term times your constant. So number 1, I'm going to multiply, and we'll just use this as an example. I'm going to multiply 3 times 5. Or we'll say 3 times negative 5. That works. Okay, so 3 times negative 5 is negative 15. So that is like my original constant term. Okay, so I need a number times a number that is going to give me that. Okay, and then I want to also look at my middle term again, which is negative 2. I still need something plus something to equal negative 2. So very similar to what we were doing when we had a equals 1, but there's some extra steps involved. Okay, so let's look at this first. Negative 15 is negative 5 times 3, and negative 2 is negative 5 plus 3. So that's what I'm going to use. But then we have to do what we call split the middle term. So splitting the middle term involves rewrite the original trinomial, but it's going to end up with 4 terms, and I'm going to show you what I mean by that. Okay, so what I'm going to do is I'm going to circle this in a different color. I'm going to take this negative 2p, and I'm going to rewrite it using this and this. So using the negative 5 and the 3, I'm going to rewrite that as negative 5p and plus 3p. So let me show you what I mean by that. So I'm going to rewrite the original trinomial, 3p squared, but then I'm going to use minus 5p plus 3p still equals negative 2p. Negative 5p plus 3p still equals negative 2p. So all I'm doing is I'm rewriting it just in a different way. I'm splitting that middle term into 2 terms that when I add them together, I still have that middle term. Okay, and then I just bring down that the minus 5. All right, then what I do after that is I use grouping, which you should have done before, to factor. Let me show you what that looks like. So now what I'm going to do is I'm going to divide this thing down the middle. Okay, so I'm going to divide it into this binomial and this binomial, and I'm going to factor each of those. I'm going to take out the greatest common factor of each of those binomials. So I've got this binomial right here. Well, the greatest common factor over here is just p. So all I can do is take out the p, and what I'm left with is 3p minus 5. Because when I took out p from here, I've got 3p. And then when I take out the p from here, I've got minus 5. Okay? And then I'm going to take out over here just a 1. There's nothing else I can factor out of this, this binomial right here. So you can always factor out a 1. All right, and then when I take out a 1, I still have 3p minus 5. So let me show you what you're looking for. You're looking for this right here and this right here to be the same thing. Basically, that's the greatest common factor of this and this. So what I'm doing is essentially I'm pulling out a greatest common factor, but you don't have to worry about that. Just understand that if this and this are the same, then that is one of your binomials, 3p minus 5. Okay, your other binomial is this part and this part. So your other binomial is p plus 1, and that is this original trinomial factored. If you were to multiply all this back out, you would get this trinomial right here, 3p squared, that's negative 5p, and positive 3p, which is negative 2p. Negative 5 times 1 is negative 5. All right, let's try another one. Okay, this is number 3. So remember, our first step was to multiply the coefficient times the constant. Well, that's 12. Whoops, 12. And then take our middle term, negative 8. Look for a factor pair for 12. That when I use those same 2 numbers, I get negative 8. So it's going to be 2 negative numbers. it's going to be 6 and 2, so negative 6 and negative 2, and negative 6 plus negative 2 equals negative 8. So when I rewrite this middle term, I'm going to use negative 6n and negative 2n. So I'm going to rewrite the whole thing, 3n squared. Instead of writing negative 8n, I'm going to write this right here, negative 6n minus 2n, and then continue with the rest of the trinomial. So I've split my middle term. Now I'm going to divide this thing down the middle. You can use parentheses too, like you could do this if you wanted to. If you think that's easier, that's fine. Now I need to look for a greatest common factor for each of these binomials. Greatest common factor for 3n squared and negative 6n is going to be 3n. So when I factor that, which is opposite of distributive property, I'm left with n minus 2. Okay, so I want you to keep in mind that in my parentheses over here, I want to have n minus 2. So what I'm going to take out of this is a negative 2. So when I take negative 2 out of this, I'm left with n. When I divide 4 by negative 2, I have minus 2. So again, remember, I want this and this to be the same thing because that's my first factor, and then my second factor is what's left over on the outside. So it looks like this, n minus 2 times 3n minus 2. And it doesn't matter which order you put these in. You could have put the 3n minus 2 first and the n minus 2 second. Okay, so this is number 5. Multiply 2 times 5, that's 10. And then my middle term is 11. Of course, that's going to be 10 times 1 and 10 plus 1. So my middle term is going to get split into 10v and 1v. 2v squared, doesn't all look like a v, 2v squared plus 10v plus 1v plus 5. Okay, split that. And I'm going to take out a 2v over here. That's going to be v plus 5. And then you can, remember, you can always take out a 1. You have to take out something. So let's take out a 1, v plus 5. These two match, so my first binomial is v plus 5. My pen is not working today. And my second binomial, is 2v plus 1. Okay, so that's the answer there. So instead of doing number 7, I decided to do number 8 because I wanted to show you that if you do see that these three coefficients have, the two coefficients and the constant have a factor in common, you can still pull out that greatest common factor before you do anything else to it. So let's take out a 3 from these. So I'm going to take out greatest common factor 3. So I have 3k squared plus 22k plus 7. So then I'm working with just a little bit smaller numbers. So our 3 is not going to disappear. It's gonna be in the final answer, but I'm just gonna kind of hold it to the side for a second and work with this trinomial right here. So 3 times 7 is 21. My middle term is 22. Of course, that's going to be 21 times 1, 21 plus 1. So when I split my middle term, it's going to be 21k and 1k. So again, I'm going to leave the 3 for a minute. I'm going to just rewrite this trinomial right here and split the middle term. And then I'm going to divide this in the middle. Let's see, what can I take out here? 3k. That's k plus 7. And then I'm just going to take out a 1 right here. Sometimes you can take out more than just a 1, but you can always take out that 1. Okay, so now these two are the same. So that's one of the factors. And then, of course, this is the other factor, other binomial. Don't forget, though, you had that 3 on the outside. So we need the original 3, which is this right here. And then this binomial, k plus 7. And then the green one, 3k plus 1. All right, and so that is the answer. So the last problem I do want to look at with you is number 7, and only because we don't have a greatest common factor that we can pull out of this one. So our numbers are going to end up being kind of large. So when we multiply the 7 times the 28, 7 times 28 is 196. And then when I start looking for a factor pair for 196 that adds up to 53, that can be kind of difficult to do in my head. And even with a calculator, I'd just be like guessing numbers. So I wanted to show you on the TI-84 how you can do that using your table. The first thing we want to do is we want to enter y equals, and then we want to enter, and I've already entered it here, 196 divided by x. So enter 196 divided by, and then x. So after that, I want you just to make sure on your calculator, hit second and then window. Want to make sure that this number right here, which it isn't, is 1, where it says table start, and then also the delta table is 1 also, and then these two are set on auto and not ask. Okay, so then after you do that, you should be able to go to second and then graph, which brings you to your table. And then what you'll see is all your values for x and then the values for y if y equals 196 divided by x. So what you want to do is you want to look at the ones that end up being whole numbers. So 2 times 98 equals 196. Well, this one, 3 times 65 and a third, we can't use that. We need whole numbers. 4 times 49, 7 times 28. And so if you just keep scrolling down, you can find all the factor pairs that are whole numbers for 196. So let's look again. I don't even remember the number. The number I'm looking for is 53. So I'm looking for two numbers that add up to 53. So let me go back up. So 49 and 4 they add up to 53. So those are the two numbers I'm actually going to use here. I'm going to use 49 times 4, and then 49a, whoops, that should be a plus, sorry, plus 4a is how I'm going to divide that 53. So then when I rewrite it, 7a squared plus 49a plus 4a plus 28. So then I can divide these up into two binomials again and find the greatest common factor of each one. So and I'm going to finish this one, but I really just wanted to show you how to find factor pairs for a larger number if you need it. So let's do greatest common factor of 7a squared and 49a is going to be 7a. And then in parentheses is a plus 7. And then over here I actually have a greatest common factor this time. It's going to be 4 plus 4. And again, a plus 7 in parentheses. So now I have my a plus 7 is common. So that one's going to be one of the binomials. And then 7a plus 4 is going to be the other binomial. So let's see, a plus 7, 7a plus 4 is the other one. All right, so you only have like 3 more on that page that you need to do by yourself if you watch the whole video. Let me know if you have any questions.